G'day everyone, we're up to the next stage of building up this VG30 DETT engine. We've already stripped it down and we've already built the heads in another video. So now it's time to fit the crankshaft and fit the pistons. Now in this video, we'll go through how to do all that as closely with the book as possible that we can right here at home. We'll go ahead and we'll fit the pistons. We'll go through how to do that. And we'll also measure that crankshaft end float as well. We're fitting all new bearings to the rods and to the mains as well. But before we can do any of that, we're going to clean up this block. We need to make sure we block the top of the deck and measure it and make sure there's no warpage or uneven surfaces there. I'll give it a quick hone as well. We'll measure them bores and make sure everything still is in spec, and then we'll thoroughly clean it. We need to make sure everything is very, very clean. All the gasket surfaces are clean, all the oil galleries are clean and blown out and dry before we go ahead and build it. So I'll get that done, and then we can fit the crankshaft and fit these pistons and get this on the next stage of assembly. Okay, so I've just blocked the deck with a bit of emery and some CRC around a flat plate just to clean it up so we can see if there's any need to machine it. Now I've got a straight edge here and a 4 thou feeler gauge. If the feeler gauge passes underneath the ruler, then we may need to machine the block. There is a limit for that, and that is 8 thou. And that includes the cylinder head as well. So you have to add them together. If you machine the head and the block, it must be 8 thou total. Okay, next up we have the under piston oil squirters. We can see them here. I numbered them when I took them off, so they're going to go back where they came from. They do have a gasket. There's meant to be a gasket between the block and the under piston squirt, so make sure we fit new gaskets there. They also have small M6 bolts, and they have a spring washer, which is best to replace as well. I couldn't find a spec for these at all, so I put a little bit of Loctite on the bolts. I fitted all of them, and I torqued them up to around 10 to 12 Newton meters, which is pretty tight for an M6. I figured that's on the upper end of the scale, and that will make sure they don't come off. But that is not gospel, of course. That is just the spec I did them to. 10 to 12 Newton meters. They didn't break. They're not going to come out. Not sure the spec, but we'll mark them off as tight. We'll move on. We are ready to fit the crankshaft. I've gone with ACL race bearings. They're a standard size bearing. You can get extra oil clearance as well if you need them. Of course, if your crank is undersized, make sure you get the right size bearings. And if you're going with the Nissan OEM bearings, you do have to get the right grades. There are part numbers on the bearings that come out, which helps a lot. And of course, we have the grades stamped on the blocks. The block has numbers stamped on it, as does the crankshaft. We'll have a look at that when we grab the crank, but we do have to buy the right bearing to suit the grade that the block and the crank were machined to originally. I've also got some Plastigauge here. We're going to use Plastigauge to measure the oil clearance. So let's put these bearings in and let's get that crank fitted. Okay, so I've got the crankshaft here. I'm going to clean it thoroughly, get all of those holes cleaned out, make sure all them galleries are nice and clean. I've buffed any rust off from where that timing gear was, and then we can fit the new bearings to the block. You can see there's a part number, it says standard, and that is an upper bearing. All the upper bearings for the mains have the holes in them for the oil to get to the crankshaft. So make sure we fit them in the correct position. We can see here the oil holes are obviously in the upper bearings, and the rear one has the thrust. The two middle ones are the narrow ones, and the front one is a little bit wider. So they do need to go in the correct positions. You can't really get it wrong. Just make sure we put the uppers in the right spot. The two middle ones are the same, and the back one has the thrusts on it. After that, I'm going to use a little bit of this assembly lube. It's a special kind of assembly lube that makes sure that this oil stays around the crank. We can drop the crank in. It might be a little bit tight at the rear there because, of course, we have the thrust. Make sure it turns smoothly. It should do, of course. Okay, same as before here. We've got the thrust bearing to go to the back. We've got the two skinny bearings in the middle, and at the front we have the wider bearing. We've cleaned and made sure everything is dry, and we've dried it with contact cleaner as well. We can go ahead and fit these new bearings to the cradle. Now I'm going to reuse all the bolts as well. We just have to use engine oil on the bolts, and I'm also going to use that Plastigauge when we fit it, just to make sure our oil clearance is correct with these new bearings. We want to make sure that clearance is correct, or we'll have a very tight crankshaft which might spin a bearing, or no oil pressure because our clearance is too much. Okay, I've just fitted a strand of this Plastigauge. It's very small stuff, a little bit of green there. I fitted a strand on top of the crankshaft journal there, and we fitted this cradle with our new bearings dry. There's no oil on it. It's fitted dry. We'll take it back off to oil everything. We're going to compare just how much clearance we have. So I'll pull these bolts down. We're going to oil the bolts and the bolt heads, and we'll pull them all down and we'll torque these two only. We're going to oil the threads. We're going to oil under the head as well. And we can oil up here. Make sure everything gets lots of engine oil. You can never have enough, really. Put them down and then you can whack some oil in like this. Just try not to hydraulic them. We'll pull them all down, and we're going to pull them down with a speed brace. And undo them as well. Now if we use our scale here, we've got 3 thou all the way up to 1 thou. We're looking for somewhere between 1 and 2 thou. It's definitely a bigger clearance than 1. Probably 1.5, maybe 2, depending on where we see it. If we hit it in the middle, it's about 2 thou, maybe a little bit more than 1.5, but that is perfect. We have a maximum of 3.5 thou, and we're certainly nowhere near that. We've crushed it a lot more than that. I'd say we're around 2 thou. That is perfect. We'll clean it off, oil everything, and put it together. We can put all of that together now. If you want to check, you can Plastigauge every single one, but I know that all the journals are the same, all the bearings are standard. There should be no reason to suspect otherwise. We'll also do Plastigauge when we fit the conrods, just to be sure. We'll do one of those as well. But for now, we'll put the cradle on with lots of oil on the bolts, and we'll torque it all down nice and evenly to have the bottom end together. Now we're just going to pull these down evenly with the speed brace. Pull them down just till they touch. You may need to tap the cradle down a little bit as well, just to make sure it's home. Just tap it with a rubber hammer. Just make sure it's all the way home. It should be a tight fit. A tight fit's a good thing. That's what we want. And mine certainly was. I needed to give it a good tap just to make sure it was all the way home. Now we're going to tighten these down just by hand, just like that. Okay, so here's the torque procedure for the bottom cradle or their main caps, and this is the order in which we do them. I'm doing it up to 74 foot-pounds, and you may notice that my pistons are actually already fitted here. I did actually remove the cradle when I didn't get enough crankshaft end float earlier. I checked it with all the pistons in, and it was a little bit low, so I pulled that rear main bearing out, checked it over, and just made sure that everything was sweet, put it all back together, and I got some pretty good end float after. So of course, this is the torquing procedure, and I'm doing it for a second time. That's the order we do it in. Make sure you double check everything. And here is the crankshaft end float I'm talking about. It isn't very good. It's kind of bouncing back. It's not getting the spec that I want. So I did take out that rear main cap just to double check a few things. Next, we have the piston ring end gap. This is an upper ring. Here is the spec here. It is around 8 thou to about 16. It's probably best if you push the ring a bit further down the bore than I did. According to the spec, it should be at least a piston width down the bore. So probably best to push it a bit further down the bore. You may find the top of the bore is a bit more worn than lower down, and you might get a better result. Anyway, I checked it with an 8 thou feeler gauge and a 16, I believe that was. If the 8 thou fits and the 16 doesn't, you're within spec and you're all sweet. If the 8 thou doesn't fit, you may need to grind a little bit off the ring. And if the 16 thou does fit, then you may have an oversized bore or your ring isn't quite right. Of course, the middle ring has its own spec as well. That is around about 20 thou to 30 thou. It's quite a bit more. Once again, push it further down the bore than I did here. You'll probably get a better result. And just make sure that the 30 thou, in my case, the biggest one I had was, I think, was a 27. Doesn't quite fit. It's actually very, very tight. And I'm happy to be on the upper spec. Next, we're going to go ahead and we'll fit the conrod bearings. They have a tang on them. You can see here, you can't really get it too wrong. Uppers and lowers are actually the same. There's an oil hole that must line up, and you can see the light of day through it. Just here, you can see a bit of light through there, which means the hole lines up. Of course, we want the big end nice and dry. Fit those shells, of course, in the bottom cap as well is the same, nice and clean and dry. Fit it with the tang. And you can see here, there's a witness mark where the tangs actually lined up with each other. So it's tang to tang when you put it together on the crankshaft. You can also see that the number of the conrod, whether it's number 4, 5, or 6, the numbers should line up. So there'll be a number sideways, which is the grade, and the up and down vertical number, the two numbers should line up. That tells you that the cap is in the right position. Now, fitting the piston rings, pretty straightforward. We're just got to make sure we get the orientation right. And the service manual tells us that as well. With the dot facing to the front of the engine, we're going to fit the rings in a specific order. We have the oil control ring here, and the join of the oil control ring goes at around about 10 o'clock, 11 o'clock. Then we have the lower ring, which is also an oil control ring. Now that goes to about 4 or 5 o'clock. We can see here on the diagram. And then we have the next oil control ring, which is the upper control ring. That goes at around about 2 o'clock. And that is all of our oil control rings. There's 3 there that sit on that bottom land. Then we can fit the middle ring. Now the middle ring itself, it does matter the orientation. The middle ring has a marking on it. That must be facing up. And that is our lower compression ring. Middle ring or lower compression ring, that sits at around about 7 or 8 o'clock. And then we have our upper compression ring, which also has a dot or a mark at the top, and make sure that sits at around about 1 or 2 o'clock. There is an end gap measurement. I didn't bother doing it, but you can. Make sure you check that with a feeler gauge if you really want to. My rings were pretty tight. The pistons didn't seem to have too much wear there. I was happy that they were okay just to fit. Now we have the piston ring compressor here. Of course, this is just one you can buy off the shelf. Make sure it goes all the way down to at least 87 millimeters. I tightened it up quite a bit with a lot of oil in it. We're going to oil the bore quite a bit. You can see I've got the engine sitting on a stand on top of some steel so I can mop it up. A lot of oil on our big end bearing, and of course that dot needs to go to the front of the engine. Nice and carefully drop that conrod down the bore, don't scratch it, and then we can just tap it in with a piece of rubber like this. It's actually a rubber hammer. Make sure we hold the piston ring compressor very hard against the block. We don't want them rings escaping. If it stops or it becomes tight, don't keep hitting it. You may break a ring. Stop and have a look. It should go in very easily, and just watch that conrod on the crank. I put the crank at bottom dead center, and then I can tap it home like this while grabbing the bottom end of the conrod and guiding it onto the crank. And then of course we can swing the engine over. The piston shouldn't fall out. We can oil up our bottom cap. Of course I did a Plastigauge on this as well. Oil everything up, oil the bolts, heaps of oil, and make sure we do tang to tang. We make sure that that number, the sideways number, is at the top in this case, and the vertical number should line up. So whether it's number 33 or number 44, it should line up. As long as we do tang to tang in this case, everything should be correct. But check the book and make sure it goes the same way we stripped it. Those numbers should line up and everything should be in the right orientation. We wind it down with a speed brace first so we can feel if there's any issues. Of course, like I said earlier, we did Plastigauge it. We've got between 1 and 1.5 thou of clearance, which is very good. And then we can torque them up. There's 2 torquing procedures. One is a torque turn. The other is just a straight out torque. I just went for 33 foot-pounds, the straight out torque, and that is the upper limit of that spec. Okay, so the oil pump is the last bit of this video. We're going to strip the oil pump down, clean everything, and reassemble it. We may need to hit some of these bolts with a punch because they are a tapered head. Quick hit with a punch and they can undo. If you've got a screwdriver like this, it can be driven by a spanner. That helps as well. Just be careful and give them a hit with a punch. It makes it way easier to get them out without rounding them off. There's no gasket between here and the plate, between the pump and this plate, because it's all internal. Make sure it all spins, everything's happy. We can see here, this is the inlet side. That is the outlet side that goes to the engine. It sucks it in through the bottom and delivers it to the engine there. And there is a relief valve I'm pulling off here. That's on the pressure side. It's got 2 springs inside it, 1, 2, and there is a relief valve. Basically, that maintains pressure in the system and will dump oil back to the suction side of the pump if the pressure gets too high. It maintains pressure and also limits maximum pressure as well. It's not a bad condition pump. There's a few scores and marks, but I'm going to use it again. All the teeth look pretty good. It's never had any real contamination go through it. It's a little bit worn, but I think it's going to be just fine. There are a lot of measurements for this in the book. And of course, we are here to change out that main seal as well. That's effectively our front main seal. Okay, getting that main seal out, I've just used an 1 3/8" socket. It fit pretty well, maybe a little bit bigger would be better. Couple of hits and it falls out pretty easily. Make sure you note the direction. Spring always goes to oil, that's pretty normal. So the spring is to the oil, the open side, and the flat face faces out. Once we've cleaned it up, I cleaned it with some degreaser and a wire brush, made sure it's all very clean inside and out. So we can fit that new seal. Just tap it home with the same socket with the solid face facing out and the spring to oil, of course, and just hit it till it's flush. There is a shoulder it goes against inside. You can't really go too wrong. Just make sure it's nice and square inside that pump housing. Once we've done that, we can start reassembly. So of course, we're going to fit the relief valve first, make sure it's clean, oil up that plunger. The solid side goes towards the pressure. We can fit our 2 springs, make sure both springs are fitted, and we can fit with a new gasket or a cleaned up old gasket. We torqued that up. I torqued it to 30 foot-pounds. There is a spec somewhere between 29 and 50, I think it was. So I torqued up to 30 foot-pounds. It's pretty tight. I don't think that relief valve's going anywhere. We'll oil up where the gear interacts with the front main seal. Drop that gear in. It should be a nice fit. It should spin nicely just like that. And we'll fit our ring gear as well. Clean it up. Lots of oil on that ring gear and make sure everything goes home easily. Mine got a little bit stuck. You shouldn't need to force it in. Just a couple of taps with something plastic, in this case with my screwdriver. It fell in quite easily and it turns quite easily as well. I'm going to put a bit of oil in there just to clean everything up. Make sure we just throw some oil around just to make sure that everything's got oil when it needs it, because on startup we may not have very good oil pressure if we haven't primed a bit of oil into this pump. Okay, so we're going to fit the backing plate to the pump. It only goes in one direction. Fit all the screws and just pull them down nice and evenly with a screwdriver. And there is a torque spec for them. We're going to torque them up to around about 5 Newton meters. That's on the higher end of the scale. If we don't have a torque wrench for this, we can just pull them down with a spanner and a screwdriver, but it's best to torque them if we can. I'm going to put a little bit of gasket maker, just the tiniest skim film, just to help the gasket on the engine block here for any imperfections. Of course, we fit the gasket, tiny bit of gasket maker on the pump as well. We can line up the drive on the crank and we can go ahead and pull the pump down against that gasket. Make sure the gasket goes on the block, of course. M6 bolts, the shorter ones go in the top 2, as you can see here. And there's slightly longer ones around that delivery port. They have a small shank on them and they have a torque as well. We're going to torque them up to around about 7 to 8 Newton meters. The 2 bottom ones, the longer ones, I've put spacers on for now. They have a slightly higher torque. They're an M8 of around about 25 Newton meters. Of course, we need to put some anti-seize on the crank. Well, I'm going to put some anti-seize on the crank at least, because that gear was very hard to get off on strip and it was actually rusted to the crank. So I figure a little bit of anti-seize on the crank, a very small amount, might help my new gear not rust on. Don't forget this little backing plate that goes between the pump and the gear. The gear only goes in one direction. There is a timing mark that must face out. Make sure that timing mark faces out because we need it to time the engine. And of course, it lines up with the keyway as well. I'm just going to tap it home with a hammer. It's very tight on the keyway, and I think that's a good thing. And of course, once we've tapped it all the way home, there is another plate that goes on the outside as well to hold that timing belt on. Of course, we'll take that off when we fit the timing belt. We'll just put it on there for now so we don't forget it. That's pretty much the job done. That's as far as we're getting today. Thank you very much for watching.